Welcome back to our channel Electron Chemistry tutorial. In previous video we have done some objective bits from Chemical Kinetics. Let us discuss some more bits from same chapter. Okay. Before that, let's see some important points from remaining Chemical Kinetics. Order of reaction. So order of reaction, how to define? Simply suppose you can take any rate law rate equation. Suppose A plus B gives rise to product rate law. R is equals to K into concentration of A power X concentration of B power Y. The sum of the powers of the concentration terms of the reactants in a rate law rate equation is known as simply order of the reaction. Okay. Now for zero order reaction, integrated rate equation for zero order, K is equals to X by T. For first order, K is equals to 2.303 by T log A by A minus X. Okay. So this is very important formula. So next, half-life. How to define half-life? Time required for the 50% completion of the reaction. So simply denoted as T50 or T 0.5 or T half simply. So it's proportional to 1 by A power n minus 1. A means initial concentration. Initial concentration of our reactants. So this is order of the reaction. Okay. For two conditions, T half 1 by T half 2 is equals to inversely proportional. No? So that's why A2 by A1 whole power n minus 1. So this problem also very important. So this T half values for first order, zero order reaction, T half is equals to A by 2K for zero order. For first order reaction, T half is equals 0.693 by K. Okay. So then simply here T half is equals to, remember these 3 points also. So these are very useful to our objective bits. T 75% means time required for the completion of 75% of the reaction is nothing but 2 T halves. Suppose here, let's see here. Initial concentration 100%, there is no reaction started, there is no decrease in the concentration. So after T half means after completion of 50% reaction, 50% remaining. So means 50% reactants are reacted, remaining 50%. So next in that 50%, so 25% reacted, 20% remaining. Okay. So here T1 T half, 2 T halves. So 2 T halves nothing but the reaction completed, 75% means remaining unreacted percentage is 25%. So in that half, 12.5 in that half, so up to 10 T halves means T 99% is equals to 10 T halves. Okay. So remember this. So 93.75 required 4 T halves. 1, 2, 3, 4 no. So this is what? Unreacted percentage. Suppose you want to get more clarity. 100 minus 6.25. How much? 93.75. For completion of 93.75, how many T halves are required here? 4 T halves. For completion of 0.01 means 99.9% completed. 0.01 is remaining unreacted percentage. So time required for the 99.9% means how many T halves required? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So time required for the 99.9% reaction will 10 into T half. So just remember these 3 steps only. So to understand these 3 steps, so I will show you. So this one. Clear? 100% in 100%, 50% reacted, remaining 50%. So 50% disappears. So remaining percentage. In that 50% means 25% disappear, remaining 25%. So in 25%, 50% means 12.5 disappear, so remaining 12.5. Okay. So in that same half, finally we will get 0.01. So almost all reactions completed, 99.9% only, not 100%. Clear? That's all. Let's do some bits on this formulas. Okay. Now 11th problem. In the previous video 10 problems over, no? 10 bits over. So that's why 11th bit. So see here, 2 moles of NO, nitric oxide reacts with Cl2 gives us 2 moles of NOCl. So this reaction was studied at minus 10 degrees Celsius and following data was obtained. So here concentration of means not nothing but initial concentration of nitric oxide 0.1 first experiment. So this is also 0.1. So then rate 0.18. Here concentration same but here doubled. So here almost doubled. Next third experiment. So concentration of NO doubled. So Cl2 is same but here almost 4 times. Okay. So simply by this data what you get simply, so rate of the reaction depends on both NO and Cl2. So that's why, so this is taken as one first equation, second equation, third equation. Got it? So simply write down rate law. R is equals to K into concentration of what? NO power X, concentration of Cl2 power Y. We have to calculate this X and Y here. Overall order of a reaction. Okay. Now, see here, equation 1 nothing but Cl simply concentration. Instead of concentration of NO, we can write 0.10. So instead of Cl2, 0.10, instead of R, 0.18. Clear, everybody? So simply for that, so equation 2 divided by 1. See here, listen to me carefully. So simply here this is what R1, R2, R3. So what is the R1 value? So 2 second equation, no, R2 is nothing but 0.35, R1 0.18 is equals to K into concentration of NO in second equation 0.1 power X, Cl2 0.2 power Y. Next here in first equation concentration of concentration of NO 0.10 again 0.10. Next here 0.10. You can take simply 0.1 only. So cancellation, mutually cancel KK. 0.1 power X cancel. So 0.1 0.2 2 times. So here almost 18 2 is 36, almost 1.999 nothing but simply 2. So simply what you get, 2 is equals to 2 power Y. So here bases are same, automatically powers are equal. Y is equals to 1. Okay. So order with respect to Cl2 is 1. Clear? Next, by equation 3 by 2. So simply what? R3 by R2. Okay. So R3 by R2 is nothing but R3 value 1.40. Next 0.35 is equals to K into concentration of NO in third equation 0.20 power X, 0.20 power Y. So here K into concentration of NO 0.10 power X. Next 0.20 power Y. So KK cancel. So here these Y values are cancel. Next here this is 1s are 2s are. So this is almost 4 times. Okay. So what you get simply 4 is equals to 2 power X. So then we need to write same basis nothing but 2 square is equals to 2 power X. So bases are same, automatically powers are equal. Okay. So order with respect to x is 2. So therefore overall order R is equals to K into concentration of NO power 2, concentration of Cl2 power 1. So what is the order of reaction? N is the sum of the powers of the concentration terms. So what is order? 3. Clear? 12th problem. So this is previous bit 2021 March 16th. So JEE mains. These 11th question, 12th questions are previous questions, 2021 March JEE mains. So they are present in JEE mains paper. See here, for the non-stoichiometric reaction, 2A plus B gives rise to C plus D. The following kinetic data were obtained in 3 separate experiments, all at 298 kelvins only. So then what is the data? Concentration of A 0.1, first experiment here, B also 0.1, or rate of the reaction 1.2 in 10 power what? -3. So this is simply equation 1. Next here, B is doubled, A kept constant, concentration of A kept constant, but B is doubled, but there is no change in the rate of a reaction. Simply what you get here? So by increasing this B, there is no change in the rate of the reaction, speed of the reaction, nothing but the speed is not depends on the concentration of B. Clear? Now in third experiment, A concentration is doubled, so this is constant, so but rate also doubled. Simply rate depends on the A. Depends on the A. Okay. So that's why write down rate law. R is equals to K into concentration of A power X, concentration of B power Y, but not depends on the B, nothing but power 0. Order with respect to B is 0 simply. Okay, but now we have to calculate only order with respect to X only. So now for order with respect to X, order with respect to A, so we need to take equation 3 and equation 1. Equation 3 by 1 only. So we will get R3 by R1, nothing but R3 is now what? Simply here R3 2.4 into 10 power minus what? 3 by 1.2 into 10 power minus 3. That is equals to K into concentration of what? 3. Concentration of A 0.2 power X, concentration of B power Y. Sorry, concentration of B nothing but 0.1 power Y. K into concentration of first equation A 0, concentration of A 0.1 power X, concentration of B 0.1 power Y. Okay. So this is almost 2 times. Okay. So 2 is equals to 1 za 2 za 2 power X. So this is 1. So simply what you get? Order with respect to A is 1. So that is simply R is equals to K into concentration of A power 1. Okay. So this is what rate law for formation of C. Got it? Formation of C nothing but C is a product now. So we should write rate law for only reactants but not products. Okay. So simply, so what do you get from this data? So simply reaction A2A gives rise to C. Okay. So ignore the D. So what is the rate law? R is equals to K into concentration of A power 1. So not equal. So this don't get confused with the stoichiometric coefficient and order. So they are maybe equal or not equal. So maybe equal, molecularity and order and both are same. Clear? this is also represented as R nothing but change in concentration. Change in concentration by change in time. That is equals to K into concentration of A power X. So they given as answer like this. So that's why instead of R change in concentration, change in time, so simply K is equals to A power 1. Clear? You have to select this one or this one. Next. See here, for the reaction A plus 2B gives rise to products. Rate law is given as R is equals to K into concentration of A, concentration of B power 2. If A is present in large excess, A is present in large excess, the order of the reaction is what? Okay. So A is present in large excess, nothing but R is equals to K into concentration of A, concentration of B power 2. Okay. Now order is what? 1 plus 2. But A concentration is a large excess. So large excess nothing but the rate of the reaction now depends on the excess concentration of the reactants. Clear? So that's why order with respect to A is 0. So then automatically order with respect to B is 2. Okay. So what is the final order here? N is equals to 0 plus 2 is nothing but 2 only. Clear? Next, the first order reaction with respect to A, with respect to reactant A, has a rate constant 2.303 per minute. If we start concentration of A is 0.5 moles per liter, when would concentration of A reaches the value of 0.05? Got it? See here, reactants what? 8. A is a reactant, gives products. A is a reactant, gives products. So initially time is 0. So initial concentration is 0.5. So after some time, T time, so it will reach as 0.05. So for which time, for what time it reaches? 0.05 from 0.5. That is the question. So how to find out that? First order reaction integrated rate equation formula. K is equals to 2.303 by T log to the base 10 of A by A minus X. So this is initial concentration A. So simply after T time means A minus X. Simply here we have to calculate time now. So that's why T is equals to 2.303 by K log initial concentration how much? 0.5. Final concentration reaches to the 0.05. So K is given as simply rate constant. Same value simply 2.303. Okay. Here we will get T is equals to what? Log 0.1 by 0.01. So that is nothing but simply log 10. Log 10 to the base 10. Log to the base 10 of 10 value is 1. T is equals to 1 minute. Okay, so that is the answer. Next, 15th one. 99% of first order reaction is completed in 8 minutes. When will 99.9% of the reaction complete? Okay. A didn't give anything, but we can calculate the time. I will show you. So simply, what he asked simply K 99%. So you can compare the 99% and 99.9%. Okay. What is the rate constant for first order? K is nothing but 2.303 by T log A by A minus X. So here also same. K is equals to 2.303 by T log A by A minus X. Listen to me. Here 99% reaction is completed in 8 minutes. No, so here you can take 8. You need to write 8 minutes here. So simply here 2.303 by 8 log initial concentration, nothing but percentages, no, initial concentration you taken as 100 minus 99% completed. X is the completed percentage. Okay. Now here 2.303 by T we have to calculate this time. Log initial concentration, again we need to take 100 by 100 minus 99.9%. Okay. Now here 2.303 by 8 log 100 by 1 only. Here 2.303 by T log 100 by so much 0.1. Okay. Next, so here 2.303 mutually cancelled. Okay. So simply log 100 nothing but 10 square. Okay. So simply 10 square means 2 log 10 by 8, that is equals to this 0.1 goes to numerator, so then 100 will convert into 1000. So 1000 means what? 10 cube. So 10 cube means 3 log 10. Okay. So simply 3 log 10 by T. So log 10 mutually cancelled. So simply here 2 by 8 1 za 4 za. Okay. So now T is equals to 4 into 3 means 12 minutes. Okay. Clear? Next 16th. This is also previous bit. So it came in 2019 mains exam. Okay. Decomposition of H2O2 follows a first order reaction in 50 minutes. Listen to me. 50 minutes. Okay. The concentration of H2O2 decreases from 0.5 to 0.125 in a such decomposition. When the concentration of H2O2 reaches 0.5 m, the rate of formation of O2 will be. Now, first of all, first order reaction decomposition of H2O2 in 50 minutes. So, write down equation H2O2 decomposes to give H2O2 decomposes to give H2O plus half O2. Okay. Suppose initial concentration is time 0, initial concentration is how much is given. So, means A is nothing but 0.5. So, after 50 minutes, so A minus X is nothing but 0.125. 0.125. Now, for first order reaction, what is the formula? K is equals to 2.303 T by T log A by A minus X. 2.303 T is given as, time is given as 50 minutes log A initial concentration 0.5, final concentration 0.125. Okay. So, see here 0.125 almost 4 times, 2.303 by 50, log 4 nothing but you can write 2 log 2, 4 nothing but 2 square, no, so I am writing as a 2 log 2. So, log 2 value we know very well, how much? 2.303 by 50 into 2, 0.301. Okay. So, by multiplying these two values, we will get 0.693 by 50 into 2. So this is what K value. So this K value kept aside for few minutes. So then next go for when the concentration of H2O2 reaches 0.05, the rate of formation of O2. Means for this reaction you have to write rate expression. Simply here rate expression how to write? R is nothing but, so D delta H2O by rate expression. Delta H2O by delta H2O2 by delta T, that is equals to, this is minus, plus delta H2O by delta T, that is equals to half. So means 1 by 2. Okay, minus plus delta O2 by delta T. Okay, so we have to compare these two. Okay, so simply delta H2O2 by delta T decrease in the concentration, means rate of disappearance of H2O2 is equals to rate of appearance of O2. Okay, so now, so this also written as nothing but here, so this is what rate R. R is nothing but, R is equals to K into concentration of what? H2O2, no? Okay, so instead of this one, I am writing K into concentration of H2O2. Then 2 into delta O2 by delta T. So then here, K value right here, 0.693 into 2 by 50. Then concentration of O2 reaches to what? 0.05 is equals to 2 delta O2 by delta T. So 2 mutually cancel here. Okay. Now next 0.693 into 10 power minus 3. Simply here 6.93 into 10 power minus 4. So this is what rate of formation of O2. Okay. Next simple problem. Half-life period of first order reaction is 50 minutes. What percentage will be left over after 200 minutes? Initially suppose you can take 100 moles per liter, 100 grams. So T half is given nothing but, T half nothing but 50% reaction completed in 50 minutes. So 50% completed, nothing but 50 grams is remaining. Next after 50 minutes, so in that 50% means 25% remaining. So after 50 minutes, in that half means 12.5 grams is remaining. So means 50, 50, 51, 50. So one more 50, 56.25. So means how many 50 minutes, 50 minutes, 50 minutes, 100 minutes, 150 minutes, 200 minutes. After 200 minutes, how much is left out? How much percentage or how much percentage is left? Means 6.25% is left out. Means to 6.25 grams is remaining. So unreacted percentage after 200 minutes 6.25. Clear? 18th problem. A particular reaction rate constant K is given as 6.93 10 power minus 2 second inverse. Find out the ratio of T half by T 99.9%. Okay. First of all we have to calculate T half, then T 99. After that we have to do ratio. Okay. T half is nothing but 0.693 by K. So K is given as 6.93 into 10 power minus 2. Simply here 0.693 by same 0.693, but here 10 power minus 3. So this 10 power minus 3 will become 10 power 3. T half is calculated as 10 power 3, nothing but 1000. Okay. Now T 99.9%, nothing but 10 into T half. 1 T half value we know very well, how much? 1000. How much? 1000. So 10 into 1000. 10,000 means 10 power 4. Okay. Simply now ratio T half by T 99.9%. So T half is how much? 10 power 3. T 99.9%, 10 power 4. So how much? 1 by 10. That is nothing but 0.1 only. Okay. Next. 19th problem, 20th problems, almost same problems. Okay. So you have to do it, ma. So I will give you a hint. So here half-life of a first order reaction 30 minutes. The time required for the 93.75% completion of the reaction. Completion of the reaction means for 93 T 93.75% nothing but we need 4 T halves. Okay. So T half is given as how much? So simply multiply with 4. So you will get the answer. But that answer in hours. Okay. So that minutes convert into hours only. Okay. That is the hint, ma. So for this, if half-life of first order reaction is 10 minutes only, so then the time required for the complete 75%. So means T 75%, nothing but 2 T halves only. So T half, how much? And calculate with 2. Okay. They are simple problems. You have to do it and write the answer in the comment box. Okay. Next problem. Half-life periods, 2 half-lives. Reaction at initial concentration 0.1 and 0.01 are 2 minutes and 20 minutes respectively. Then the order of the reaction. 2 T halves are given, 2 initial concentrations are given. So what is the formula? We need to take T half 1 by T half 2, that is equals to A2 by A1 whole power n minus 1. Here we have to calculate order of the reaction. Okay. So T half initial time 2 minutes and T half 20 minutes is equals to initial concentration 0.1. Next second initial concentration 0.01 whole power n minus 1. So 1s are 10s are. So this is also 1s are 10s are. 1 by 10 is equals to 1 by 10 whole power n minus 1. So here also you can take 1. Okay. So simply bases are same, then powers are equal. N minus 1 is equals to n, nothing but n is equals to 1 plus 1. So then n is equals to what? Order of reaction is 2. So second order reaction. Second order reaction. Okay. That's all. That's all, my dear students. If you have any queries in this chapter, so please write a message on the comment box. Okay. Thank you for watching this video. Please like, share, subscribe my channel to get more videos. Thanks a lot.